Section 10.1b. So we looked last time at the sampling distribution for the difference between two proportions and how to find a confidence interval. So this time we're going to look at doing a significance test for a difference between two proportions. Okay. So a lot of times what we're looking at is the difference between two proportions is equal to some value, and most of the time that value is 0. In other words, we're saying, is there some difference between these two proportions, or are they the same roughly? Okay, and so we can write the null hypothesis as one of two ways. Either P1 minus P2 equals 0, or P1 is equal to P2. Those two things you should see are interchangeable. And so I don't really have a preference which way you write it. It's kind of up to you. Okay, and so to perform this test, we got to check conditions like always. And these conditions should look very familiar to you. Our random condition, all right, and just like we talked about in part A, we need two independent random samples or groups in a randomized experiment. Okay, for our 10% condition, if we are sampling from a larger population, both of our samples have to meet that 10% condition. And then the large counts we have to do for both samples. So n1 times p1 and n times 1 minus p1. Same thing for 2, and all of those numbers got to be at least 10. Okay, so none of that is new information. All right, so we'll look at an example. You can pause and read this. Okay, so we want to know, is there any difference in the proportion of students who eat breakfast between the two schools? So first step is state. And so our null hypothesis is that there is no difference. Okay, and then our alternative hypothesis would be that P1 minus P2 does not equal 0. Because it didn't in the problem give us a direction. So we're just saying, is it different at all? And then we have to make sure that we define our proportions. Okay, so P1 is going to be the students at school 1, and P2 is going to be the students at school 2. Okay, then we got to check our conditions. So random, we know that we have our samples were selected independently of each other and that they were both done random, so we're good there. 10% we are sampling from a larger population, so we got to check this condition for both schools, and we're good there. And then large counts, all of our numbers are at least 10, so we are good. So when we get to the do part, okay, just like our significance test last chapter, we need that standardized test statistic, and because we're dealing with proportions, that's going to be a z. All right, the issue with this formula, though, if you look down there, we have p hat 1 and p hat 2, which we know because we have sample data, but then we have p1 and p2, which is population proportions, which we don't know. Okay, and so the way we're going to deal with that issue is we're going to do something called a pooled estimate, which is basically we're going to put our two samples together and act like they came from one big sample. Okay, so we're going to add the number of successes from both of our samples, and then we're going to add the two sample sizes together, and that proportion is going to be the p hat that we're going to use in this formula in the standard deviation part. If you look on the AP formula sheet, it says the same thing but in a slightly different way. So they call their pooled estimate p hat c, so like the combined proportion, which makes sense, but it's found the same way. And then when they write out the standard deviation formula, they factor out those PCs. So like if I go back to this one, everywhere you see a p hat, like that can be factored out. And so they just write it slightly different. The math works out either way. Okay, this is what the section of the formula sheet, which is what you will get on the test and the AP exam, so it's important to know. But it tells you when P1 equals P2 is assumed, meaning our null hypothesis is that P1 equals P2, or P1 minus P2 equals 0, which is what you more commonly see written, that this is the portion of the formula that you would use for standard error, and they tell you how to find p hat c. Okay, like I said, either form will work, or if you don't want to deal with those equations because they get kind of long and messy, we can always use the calculator. All right, and so here are your directions for how to get to a two proportion z-test on either version of the calculator. So we'll go through this. All right, so we're looking for, is there convincing evidence of a difference? All right, so if you're going to use the formula, first thing we need to do is find our p hat c. So I combine the two schools together. So 19 students at school 1 and 26 students at school 2, and then 80 total students at school 1 and 150 total students at school 2. That gives me a p hat c of 0.196. All right, so on the top, p hat 1 is the proportion just at school 1. P hat 2 is the proportion just at school 2. And then the parameter that we're using is 0 because we're assuming that there is no difference. Okay, and then down here we use our P hat C for each of these. Okay, and so we get a z-score of 1.17, and then we're going to do normal CDF. Since that z-score is positive, it's going to be my lower limit, and that will give you a value of 0.121. And we have to remember that because this is a two-tailed test, we're going to multiply by 2, so our p-value is 0.242. If you decide to use the calculator, totally acceptable. I would write down your pooled estimate, your z-score, and your p-value. Okay, and then conclude just like we did last chapter. Because our p-value is greater than alpha, we're going to fail to reject. So we do not have convincing evidence of a difference between the two schools. Okay, so just a reminder that if you're going to use the calculator, which is totally acceptable, I would probably even recommend it just because that formula gets so messy, that we're just going to make sure you write down the standardized test statistic, that's a tough one to say, and the p-value, okay, and also that you name the test, okay, so somewhere we need to say that we're doing a two-sample z-test for p1 minus p2. Okay, I would do that probably in your plan step where you are stating your conditions. Okay, so the last part of this is we're just going to work through an example, and it'll pause and let you pop up and put your own answers in and then go through the solutions to check.